let's okay, this is another composite function. Let f, g, and h be mappings on the set of real numbers defined by f of x is equals to 2x plus 1, g of x is equals to s squared minus 3, and h of x is 3x plus 2. Show that f of g in brackets of h is equals to f of in bracket g of h. So we have data given. F of s is equals to 2x plus 1, g of x equals s squared minus 3, h of x equals 3x plus 2. So let us start with f of g of h. So first I have to do f of g first. F of g means what? F of g. So this is how we can represent it. So, and what is your function g is here? That is s squared minus 3. So that means f of g here is the same thing as f of s squared minus 3, because g of s is s squared minus 3, and f of g means f of s squared minus 3. So this g will turn to s squared minus 3. And remember, you have f of s is given as 2x plus 1. So that means f of s squared minus 3 will be equals, so this s now will replace s squared minus 3. So anywhere you see s, put s squared minus 3. So this will be 2 brackets s squared minus 3 plus 1. You know this is 2x. Instead of writing that x, I'll write s squared minus 3, because f of s and f of s squared minus 3, it means s is equals to s squared minus 3. So anywhere I see s, I'll put s squared minus 3. So now f of s squared minus 3 is equal to 2s squared minus 6 plus 1. That is, this 2 will open the bracket. 2 times s squared, 2s squared, 2 times 3, 6. So this will be 2s squared minus 5, because minus 6 plus 1 is minus 5. So that means with this we have found f of g, which is 2s squared minus 5. Now the function remain h, that is f of g of h. So what does this mean now? Since we've known f of g to be this, it means h will enter f of g. So see the way I will represent this now. This one means f of g, and let me do it this way, f of g of h, meaning this f of g, let me put it in bracket too, f of g of h. So h will enter f of g, and take note, this is f of g. We already know f of g as 2s squared minus 5. So if I now put x, so you can see it clearly, f of g, look at this, this one here is the same thing as f of g of x is equals to 2s squared minus 5. As in, that's what this means, f of g of x. Now, if you now have f of g of h, it means h will now enter f of g, meaning it will now be like f of g of h, as in like this. So that is how this one look like, this representation. So f of g of h, so meaning h will enter this function. So let's break it down. So f of g of h, yeah, is the same thing as f of g of h, is the same thing as this. So it means f of g, you know what is our f of g? We found it. So f of g of h, what is h? That is 3s plus 2. 3s plus 2, as in that is h. So look at it again, f of g of h. So an f of g of h is 3s plus 2. So now go back to your results here. F of g of x is equals to 2s squared, that is our result, minus 5. Now, what is f of g of 3s plus 2? So look at it, f of g of 3s plus 2. But we already found f of g of x, which is the same thing as your f of g. So anywhere you see x, you put 3s plus 2. That is the meaning. So if you are watching the video, just calm down, like break it down. See the way I explain it, you to follow the step. So f of g of h is the same thing as this representation. These two are the same, like that. And we have already found f of g of x, which is this. So now f of g of h, this h is 3s plus 2, which is the same thing as this. So we now relate the two. So since f of g of s is this, our previous result, then f of g of h, anywhere I see x, I'll put 3s plus 2. So this will be 2 brackets 3s plus 2 square minus 5, like that. So we now have f of g of 3s plus 2 equals 2 brackets 3s plus 2, another 3s plus 2 minus 5. So I will expand. So that will be 2 brackets. So expand this bracket. We have 3s times 3s. That is 9s squared. 3s again times 2. That is 6s. So plus 6s. Plus 6s again. Plus 4. So normal expansion. Then minus 5. 2 brackets 9s squared plus 12s plus 4 minus 5. So you use the 2 to open the brackets. So we have 2 times 9, 18s squared plus 24x plus 8 minus 5. So finally you have 18s squared plus 24x plus 3. So now this results is for this f of g of h. So f of g of h now is 18 s squared plus 24s plus 3. So that's the results for that one. So let's prove the other part. So we'll do the same thing again. So at least this second part will make it clearer. So let me save this one here. I'm coming back to this. So now we are using the second part. We want to show that f of g of h is equals f of in bracket g of h. So I've shown the left hand side now. So let's check the right hand side. F of g of h. So anytime you have the functions like this, you have to do what you have in the brackets first. So what do we have in the bracket? We have g of h. So let's start with that, g of h. So what I will repeat here is still like what I have done first. So this will make it clearer. So follow again. G of h means what? G of h. That's the meaning. So and what is your h? So we always do what we have in brackets first. So now what is your h? So that means g of h is equals g of, our h is 3s plus 2. So that is g of h, which is this. And remember the function g of x is equals to s squared minus 3. So that means g of x plus 2 is equal to, so anywhere you see x, put 3x plus 2. So I will have 3x plus 2 square, which is x squared minus 3. So expand. We have 3s plus 2, 3s plus 2 minus 3. So this will be 3s times 3s. That is 9s squared. Again 3s times 2. That's plus 6s. Plus 2 times 3s. That is plus 6s. Plus 2 times 2. That is 4. Then minus 3. So this is 9s squared plus 12s plus 1. So that is g of h is 9s squared plus 12s plus 1. Now let us now combine. So we are now combining this now, f of g of h. So this will now becomes f of, so the result here, g of h, we know it already. That is 9s squared plus 12s plus 1. That is 9s squared plus 12s plus 1. So remember, we have a function of x, which is 2x plus 1. So if you compare this function of s and this function of this, it means anywhere you see s, put 9s squared plus 12s plus 1. So this will be f of 9s squared plus 12s plus 1 will be equals 2 brackets. So that is, this s is now s squared, 9s squared plus 12s plus 1. So that will be 2 brackets 9s square plus 12s plus 1. That is 2x. That is 2 this. So we have another plus 1. So we have another plus 1. Let me write this. F of x. So now that is plus 1, which is this plus 1. So now expand. So we have 2 times 9, 18s square plus 24x plus 2, then plus 1. So this is 18s square plus 24s plus 3. So that means f of g of h is equals 18s square plus 24x plus 3. So now if you look at this result here and the result we got before, you see it's the same. So that means we have already proved that because the results are equal there, that means we have shown that f of g of h is equal to f of g of h. So we have proved that because we have the same results. So again, in summary, to prove or to show anything like this, do what you have in bracket first. So first find f of g. That is the meaning of this. Then any result you get for f of g. So anywhere you see x, put h inside f of g. That means you have f of g of h. So that is how the number will be entering each other. So since f of g in brackets of h, so do f of g first. Then h will now enter f of g. So like that. So anywhere you see x in f of g, you substitute the value of h. That's the meaning, and that's what we have been doing. So you can follow the steps. Likewise this, you do g of h first. Then the result of g of h will now enter f of s. So that's what you are doing. So you always do what you have in the brackets first. So we have proved that.